Intel Foundry roadmap update new 18A PT variant that enables 3D die stacking, 14A process node enablement. Intel's new theory Bhutan took the stage at the company's Intel Foundry Direct 2025 event here in San Jose, California, to ally the company's progress to each foundry initiative. Tan announced that the company is now engaging the leading customers for its upcoming 14A process node, 1.4 nanometer equivalent. The follow-up on generation of each 18A process node. Intel already has several customers who plans to tape out 14A test chips, which now come with the unannounced version of the company's backside power delivery technology dubbed PowerDirect. Tan also revealed that the company's crucial 18A node is now the risk production with volume manufacturing on schedule for later this year. Intel also revealed that it's now the 18A P extension, a high-performance variant of the 18A node is now running through the fab with the early wafers. Additionally, the company is developing a new 18A PT variant that supports favors directed 3D with the hybrid bonding interconnect, enabling the company to stack dies vertically on top of each most advanced leading edge node. The Favre Directed 3D technology is a key development because it provides a capability that rival TSMC already uses in production, most famously in AMD, the 3D V-Cache product. In fact, Intel's implementation matches TSMC's offering in a critically interconnect density measurement. On the motor side of the operation, Intel Foundry has its first production 16nm tape out in the fab now, and the company is now also engaged customers for 12nm node is developing in partnership with the UMC. And perhaps the most important development at the show revolve around Intel's continued expansion with its EDAs and intellectual property partners that provide critical tools and IP products that enables customers to develop new designs with industry standard design flow and tools. The company has also extended its Intel Foundry Accelerator Alliance program to include Chiplet Alliance and Value Chain Alliance programs. Intel Foundry's progress comes during the turbulent times in the semiconductor industry, as geopolitical divisions threaten to fracture the global chip supply chain. So Intel is currently the only US-based domestic supplier of leading-edge process node technology and advanced package capacity. A key advantage extension between the China and TSMC continue to escalate. Despite TSMC's expansion production in the US, a recent law passed by Taiwan has now prevented the company from producing its most cutting-edge tech in the United States, leaving Intel as the only domestic foundry with both leading-edge chip production and R&D. As Nanga Chandrasekaran, the Chief Technology and Operations Official of the Intel Foundries, and Kevin Buckley, the General Manager of the Foundry Services, are also slated to deliver keynote during the event, providing more details about technology and the roadmaps. We'll update this article with additional information as it becomes available, but we have plenty to share to get started. Let's take a closer look at the Intel's progress. Okay. Next. How US tariffs could impact cloud computing. First, with political uncertainty and complex global supply chains and regulations, smart enterprises will be proactive with their cloud strategies. The cloud computing industry has long been a backbone of the digital transformation. In 2022 alone, the sector surfaced $480 billion in the global valuation and its growth trajectory remains strong. However, like any other industry that relies on a physical infrastructure, cloud computing is not immune to the external factors such as trade policies. This article examines the impact of the U.S. tariffs, particularly the Section 301 tariffs on Chinese imports. I analyzed the implications for the provider enterprises and the cloud computing landscape in general. This will be an entire political discussion, focusing solely the fact their practical consequences for the current market. So understanding hardware-driven dependency. Although the cloud computing is often discussed in the abstract and software-centric sense, it's crucial to remember that it barely relies on solely the physical infrastructure, servers and storage devices, and network hardware and microprocessors. So these components serve as the building blocks for the infrastructure as a service, IaaS, and the platform as a service, PaaS, and the software as a service, SaaS, as offering the support everything that they are from enterprise resource planning systems to advanced artificial intelligence applications. Tariffs enacted under the Section 311 provision has introduced a 25% levy on more than a 250% billion worth of Chinese imports, including the component critical to the cloud infrastructure for US-based cloud provider. The sharply increased cost could disrupt supply chains and delay the deployment timelines. While processing in the short term, these challenges also created constant long-term ramifications. The short-term impact. Major cloud providers commonly referred to as hyperscalers also include Amazon App Service (AWS), the Microsoft Azure, and the Google Cloud. This initially made the observed rising cloud cost to avoid risk market share by passing them on customers. However, the tariffs on hardware components such as servers and networking equipment will be likely force them to reconsider their financial models, which means the enterprises can impact eventually, if not immediate price increases. Smaller cloud providers get hit particularly hard because they lack the financial buffer and economies of scale of the largest players enjoy. Without negotiating power by the better terms with the suppliers and the ability to quickly diversify and manufacturing, smaller firms are squeezed by the reduced margin that limit their capacity to meet service demand and invest in infrastructure expansion. China produces an estimated 30% of the world's server equipment. US tariffs have incentivized the providers to explore the alternative manufacturing hubs in the countries such as Vietnam and Taiwan and Mexico, and the diversification holds long-term benefits for ensuring the supply chain resilience, but building a new supply network in neither the quick and none others. Establishing relationships, meeting the regulatory requirement, and reconfiguring logistics and the contribution to higher the upfront costs and the delays in customers and procurement. So the enterprises consuming the public cloud services and short-term ramifications include possible price adjustment, delays in the service provisioning, such as new data centers, and potentially slower innovation cycles as providers manage these challenges. So the long-term implications as the hyperscalers stop to increases by cost by exploring the nearshoring and the regional manufacturing. These shifts may permanently change cloud price dynamics. Enterprises that rely on public cloud services may need a plan for a contract negotiations and higher costs in the coming years, particularly as hardware supply chains remain volatile. The financial strain imposed by the tariffs also has a ripple effect as indirectly is affecting the cloud adapting rates. So the companies in sections affected by the tariffs such as manufacturing, automotive, or retail, may tighten the IT budget to manage increased operational input costs. The reduced willingness of the overcapacity to invest in cloud services can delay the digital information initiatives, stalling progress in automation and scalability and agility. The geopolitical tensions and the tariffs that also highlighted the cloud providers need to comply with the increased data sovereignty laws, as India and Brazil are implementing the strategic data localization rules, entitling a provider to build a region-specific platform infrastructure. The tariff-driven supply chain challenge may further accelerate this trend, and fragmenting the global cloud networks and reducing the economy of scale that initially offers cost advantages. This realization presents long-term challenges for enterprises managing for a global operation, and they may have need to work with multiple providers to reduce the compliance across jurisdictions while maintaining consistent service level. So the practical consider for enterprises, despite all uncertainty, businesses rely on a cloud public cloud services, taking the potential risk stemming from the tariff-related disruptions. Assess provider supply chain resilience. Executives, particularly CIOs, CTOs, should engage in dialogue with the cloud provider to understand what their supply chain strategies, diversification initiatives, and the contingency plans are critical to minimize the service disruptions. Negotiation is a long-term contract looking long-term price agreement that can help enterprises avoid sudden cost spike and provide budgetary predictability despite involving the economy uncertainties. The adapted multi-cloud strategies. Multi-cloud environment can detect enterprises from dependence on a single provider, offering the flexibility and shift workloads in response to the pricing changes, the compliance needs, or geopolitical factors. To stay informed about policy development. Enterprises should monitor international trade policies and their potential impact on cloud services, so that preparing for regulatory shift will be enable firms to align their prosecution strategy more effectively and staying agile and changing the market. So these new tariffs and their effect on supply chains and pricing demonstrate how susceptible in this industry is to broader geopolitical dynamics. So all the large providers are well positioned to adapt, and smaller players and their customers navigate a more certainty environment. Adaptability and agility remain essential for both providers and enterprises. For cloud vendors, and resilience in the supply chain and efficiency in hardware will be critical. Meanwhile, enterprise leaders must balance cost containment with their broader strategic goals for digital growth. By implementing throughout the planning and proactive strategy, organization and can negative these challenges and continue to drive the value from the cloud in the year ahead. As we examine the effect for the telephone cloud computing, the importance of the non-political, fact-based perspective cannot be overstated, and the focus here is practical responses and future readiness, not rhetoric, by staying grounded in the reality of the market. The provider and enterprises alike can navigate trade policy disruption and remain competitive and innovative in the face of the shifting global dynamics. Okay, now. Next one is JADAG announces the release of the JEST 270 the 704 HBM standard. The JEDEC Solid State Technology Association, the global developer of the standard for microelectronics industry, has published its high anticipated high bandwidth memory HBM DRAM standard HBM4. The standard has been designed as an revolutionary step beyond the previous HBM3 standard, and JEST 2704 HDM4 will further enhance data processing rate while maintaining the essential features such as higher bandwidth, power efficiency, and increased capacity per die and/or stack. Because the higher bandwidth enables the higher data processing rate. The advancements introduced by the HBM4 are vital for applications that require efficient handling of the large data set and the complex calculations, including generative AI, artificial intelligence, AI, high performance computing, high-end and graphic cards and servers. The HBM4 also introduced the numerous improvements to prior versions of the standard, including the increased bandwidth with the transfer speed up to the 8 gigabit across the 2048-bit interfaces, and HBM4 boosted the total bandwidth up to 2 terabyte per sec. Double channel. The HBM4 doubled the number of independent channels per stack, from 16 channels HBM3 to 32 channels with 2 pseudo channels per channel. This provides the designers with more complex flexibility and independent ways to access to the cube. The power efficiency. JEST 270 supports vendor-specific VDDQ 0.7 volt and 0.75 volt and 0.8 volt or 0.9 volt, and a VDDC 1.0 volt or 1.050 levels, resulting in low power consumption and improved general energy efficiency. For compatibility and flexibility, the HBM4 interface definition ensures backward compatibility with the existing HBM3 controller, allowing for a seamless integration and flexibility as various applications align a single controller to work with both HBM3 and HBM4 if needed. So the direct refresh management, DRFM, as HBM4 incorporates direct RAM refresh management. The RFM4 improved low hammer integration in reliance and data availability and serviceability. RAS capacity. HBM4 support 4 high and 8 high and 12 and 16 high DRAM stack configuration with 24 gigabit or 32 gigabit die densities, providing for a higher cube density of the 64 gigabyte, 32 gigabit, 16 high. The high-performance computing platforms are evolving rapidly and require innovation in memory bandwidth as capacity, said Barry Wagner, director of the technical market at NVIDIA and JEDEC HBM subcommittee chair. Developed in collaboration with the technology industry leaders, HBM4 is designed to drive a leap forward in efficient, and high-performance computing for AI and other accelerated applications. The members are dedicated to developing the standard needed to support the technology of the future. That Mian Kodus, chairman of the JEDEC board of directors, he continues. The HBM subcommittees effort to continuously improve the HBM standard hold the potential to drive significant advance in a wide variety of the applications. The introduction of the HBM4 marks a critical step forward to a high bandwidth memory innovation, delivering the performance and efficiency and scalability required to a higher next generation of the AI and HPC and graphic workloads, and added to Joe McCree, Senior Vice President of the Corporate Fellow and a Compute Graphic CTO, AMD, that would increase the bandwidth, improve the power efficiency, and enhance capacity, and the HBM4 will be instrumental in enabling cutting-edge advanced across a wide range of the applications. So the memory bandwidth is one of the key pillars of the performance of for AI computing systems, said Nikhil Jayaram, VP, Google Cloud Silicon. JEDEC HBM4 represented the big step in a bandwidth that Google needs for generation, tracing, and inference systems. So is that we look forward to the advances in AI. HBM4 based systems will enable them to collaborate with the JEDEC to standard HBM into the future. So all JEDEC standards are available for download from the JEDEC website. For more information, use the link below. JavaScript Office selects Siemens ED tools for innovative hardware security development. April 16, 2025, Siemens Cellular Industry Software today announced that SEC the hardware security company in Japan, has adopted Siemens full IC design flow, consisting of each comprehensive portfolio of electronic design automation (EDA) and tools including the Polisa and software for digital physical awareness and place and routing implementation to develop next generation hardware security large scale integration devices, LSI devices. So established in 2023 based on this research achievement on both technology and entrepreneurship by the graduate students from the Kobe University. Sakafi is a startup company focused on the commercialization of the hardware security technologies and combining the semiconductor the security with the cryptographic technology to specialize in hardware rules evaluation and hardware security analysis. So in addition to the using a Siemens Polisa digital implementation solution, but Sakafi is also uses a range of the tools and across Siemens EDA's comprehensive integration circuit, IC design for including the Calibre software, Solid simulation suite software, and Solid design environment software, and custom IC design software to design LSI devices to be built using 180 nanometer to the 60 nanometer process node. Sakafi mission is to solving the security challenge to continue to be a rising of a more secure and safe information society by leveraging by the unique hardware noise evaluation technology and the circuit design and the implementation technology for hardware and security. So the Kazuki Munta, a co-founder of the CEO, and Sakafi, the Siemens comprehensive EDA tool portfolio gives us the tools that we need to advance our innovative hardware security research. Sakafi is a selection of the Siemens portfolio of software therefore, as the design flow is significant for us and a demonstration our leadership in Japan, providing a cutting-edge design flow to the pioneers engaged in their innovative design, as said Yuko Tsuchida, a vice president for Japan Electronic Design Automation and Siemens Digital Industry Software. And by adopting our environment comprehensive solutions, Sakafy is able to leveraging the superior performance and the capacity of our tools for their security focus on their system LSI design work. To learn more about this, Siemens is helping the startup to build the next generation of the innovative widget. Siemens Digital Industry Software helps the organization of all sizes digitally and have transformed using the software, hardware, and services from the Siemens Accelerator business for platform. Siemens software and its comprehensive digital twin enables companies to optimize their design, engineers, and manufacturing process to turn ideas and a sustainable product of the future from chips to entire systems, from product to process across the industry. The next is the AMD achieved the first TSMC end-product silicon milestone. Next generation AMD EPYC CPU, codenamed Venice, is the first the HPC product to be brought about the TSMC next generation and to node. Santa Clara, California, April 16, 2025. AMD today announced its next generation AMD EPYC processor. The codenamed Venice is the first HPC product in the industry to be taped at our industry. Tape out and brought up the TSMC's advanced 200 nanometer and 2 process technology. This heads of the strength of the AMD and the TSMC semiconductor manufacturing the partnership to the co-optimizing new design architecture with the leading-edge process technology. It also marks one level steps forward in execution of the AMD. Our data center CPU leadership and Venice on track to company next year. So the AMD also announced the successful bring up and the validation of each 5th gen AMD EPYC CPU product for TSMC's new fabrication facility in Arizona, underscoring its commitment to U.S. manufacturing. So TSMC has been a key partner for many years, and our deep collaboration with R&D and manufacturing teams enabled AMD to constantly deliver leadership products that push the limited high-performance bandwidth. Said Dr. Lisa Su, Chair and CEO, AMD Beijing, being a lead HPC customer for TSMC and to process and TSMC Regional Fab 21, a great example of how we are working closely together to drive innovation and deliver advanced technology that will power the future of the computing. We are proud to have AMD and be a leader HPC customer for our advanced 2 nanometer and process technology and TSMC Regional Fab, as the Chairman and CEO Dr. C.C. Wei. By working together, we are driving significant technology, scaling result, and better performance and power efficiency and yield for high performance silicon. Looking forward to continue to work closely with the AMD to stop the era of data computing. About AMD, for more than 50 years, AMD has driven the innovation in its high-performance computing, graphic, and visualization technologies. Billions of people are leading Fortune 500 business and cutting-edge scientific research institutions around the world early on AMD technology are focused on the developing leadership, high performance, an adaptive product that pushes the boundaries to what is possible. For more information about how the AMD is enabling today and incorporating tomorrow, inspire tomorrow, visit amd.com. Okay, thank you. Thank you for your time. See you next time.